2007 then, 3F. I'm asked to calculate the number of moles, firstly, of acid neutralized in this experiment. In the question, I'm told that I had 50 centimeters cubed and it was of a 1.0 molar HCl solution. So I'm asked for my number of moles, okay? So we use our formula, number of moles equals volume by molarity all over 1,000. Volume 50, molarity 1.0 divided by 1,000, 0.05 moles. Now you can do that alternatively as well. That 1.0 molarity is the same as writing 1.0 moles in 1,000 centimeters cubed. I don't have 1,000 centimeters cubed, I only have 50 centimeters cubed. Again, here we're multiplying volume by molarity divided by 1,000, 0.05 moles. Next, then you're asked taking the total heat capacity. And usually our formula is mc delta theta. And C here is specific heat capacity. And when I'm asked for specific heat capacity, this here is my mass. And I have to work it out with mass, okay? But in this question, I don't have to use mass because I'm actually given the total heat capacity. And that total heat capacity actually includes this work already done for you. So basically, what my formula just here is C delta theta, okay? So they've worked out this part here, okay? And I'm told that the total heat capacity here is 420. And I'm asked to calculate the heat released if 6.7 of a delta theta, a change in temperature, is recorded, okay? So 420 by 6.7 gives me an answer there of 2814. Now, this 420 is in joules, okay? When I'm talking about heat of neutralizations, in general, I am always going to be looking at it in kilojoules per mole. Okay, so that's really now what we need to get it to. And I'm just going to start off with here. Kilojoules per mole means 1 mole. But in this question, I've only used 0.05 moles. And that has released 2,814 joules. So I need to work out how many joules is in 1 mole. So I multiply by what I know and I divide by the bit left over. And that gives me 56,280 joules. I'm going to convert that into kilojoules next, and I divide by 1,000. There's 1,000 joules in a kilojoule. And that is in kilojoules per mole. And remember, heat of neutralization is always a negative, or more than always a negative answer. So you have to put in the minus sign there. So the key here was in the question, okay? So a little bit different here than the ones that we did in class, where you're actually given the total heat capacity instead of the specific heat capacity. If you're given the specific heat capacity, you have to find out what the mass is, okay? And in the question, you'd be given the density. We were given no density here. Remember, when you're looking at this mass, usually it's your MdV formula you're using. You'll be given your density and you'll be given your volume, and from that you work out your mass. But this has already been done because the key to the question here is total heat capacity. So you can just fill that directly into the equation.